Okay, it's written like this. Probability of A given B. And is read the probability of event B given event. No, that's the wrong way. What is that? Let's fix that. Probability of A given event B. How did I catch that? So basically, it's assuming that event B already happened. I'm only looking at event B stuff. And then what's the probability of A? This formula too then is, okay. Let's just erase this. The probability of A given B is equal to the probability of B and A divided by the probability of B. Any questions over that? We're all good? Okay, so we're going to be given a chart. Most conditional probabilities you'll be given a chart like this. Okay. In order to do any of this probability, you need to find all the totals. Okay. So you total everything up. So this side of the room, you guys are going to total going this way. So do all the totals going this way. This side of the room, you guys are going to do all the totals going down for me. Everyone's going to do that for me right now. Okay, Gavin, what'd you get for the total of not depressed? 210. Okay. And then, Kramer, what'd you get for the total of mildly depressed? Huh? Okay, let's do that. $233. Okay, Alex, moderately depressed. What is it? 184. Okay. Tyler, what about severely depressed? 139, good. Okay, we want to total all the totals. And what do we get for that? 766. Good. Okay, on this side of the room then. Carson, what'd you get for no social media? 135. Okay. And then, Ethan, what'd you get for the 1 minute to 30 minutes of social media?
I got 182.
182. Good. Next color. Brown. Okay, Casey, what'd you get for 31 to 60 minutes? 210. Good. And then one more. Over 60 minutes. Desiree, what'd you get for over? 239. Okay. So that's how you're going to do on your homework. You're going to have to total all this, get all those totals, okay? Then we can find probability. So the first one, the probability of mildly depressed, all you need to do is put, it's out of everybody. It doesn't limit it to anybody. It's out of everyone we talk to. We surveyed all these people. What are the chances we're going to pull somebody who's mildly depressed? Okay, so we're going to have total of totals on the bottom. And we want to find the probability of mildly depressed. It's everybody who's mildly depressed. So the total of mildly, oopsie, there's an L, depressed. So our total of our totals was 766. And we need to find how many people were mildly depressed. The 233. We do that math, we divide it, and we get about 0.03, sorry, I wrote that down wrong, 0.30 what, you guys? 4. Okay, does the 4 make the 0 go up? No, so it's just 30%, about. Any questions over that? Okay, you guys do the next one. Okay, Anton, what did you have on the bottom?
766.
Very good. 766 should be on the bottom. And then what did you have on top? 210. For our 31 to 60 would be the 210. And then we divided, and what did your percent get? Okay, do we agree, class? 27%? Good. Any questions over that? We're good? Okay, next one. So this is the probability of no social media, intersection of severely depressed, with the intersection of severely depressed. Okay? Remember the upside down U is an and. We want both of those things to occur at the same time. So this is an intersection. Okay, so we want, again, the total of totals. But on the top, we want the intersection of no social media and severely depressed. Any questions over that? So the bottom's still going to be 766. Let's see the intersection. So we're going to go to no social media. So that's these people here. And then severely depressed people. Okay, where do those two intersect? At 8. Okay. So 8 goes on top. Any questions over that? So we're going to do eight divided by 766. That gives me about 0.010. Okay, does the 0 make the 1 go up? No, you move your decimal over twice and you get 1%. Any questions over that? You're all good? Okay, you guys do the next one on your own. We had 26 over 766, which gave us about 3%. Any questions over that? We're good? Okay, now this is the new conditional statement. It says the probability of moderately depressed given we've picked somebody from the 31 to 60 minute of social media. Okay, so the second thing, this right here, needs to go on the bottom. So this is going to go right there. The second thing is always on the bottom. Because we're assuming that we're only looking at these people. We're only going to talk to these people right now. And then out of those people, I'm going to pick somebody who is moderately depressed. So on top, it's the intersection. Again, of 31 to 60 minutes. And moderately depressed. Are you guys understanding my abbreviations here? So it's the intersection of 31 to 60 minutes and moderately depressed. Goes on top. Okay. So we're going to go back up here. Where are moderately depressed? How many people are moderately depressed? Oh, let's go back up here. Sorry, 31 to 60 minutes. Let's go to 31 to 60 minutes. How many people use social media 31 to 60 minutes? 210. So 210 goes on the bottom. Any questions over that? Then we want the intersection of 31 to 60 and moderately depressed. So I'm going to go back up here. So we want, oh, different color. Moderately depressed and 30 to 60 minutes. Very good. 64. I divide that. And I get 0.304. Does the 4 make the 0 go up? No. Move your decimal over twice, and we get 30%. About. Any questions over that? We're good? Okay, do the next one on your own. Okay. In this goes on the bottom. The total. Not wanting me to write. It's like trying to, not really. Yeah. I know we're trying here. Yes, I can. It'll figure itself out in here in a second. Shh. Give it a second, guys. Okay, class, we're quiet. Thank you for your patience. We're going to come back here. Moderately depressed total goes on the bottom. Okay, the moderately depressed people are on the bottom, which is different from this other one we did, because 31 to 61 minutes was the second thing mentioned. Okay, and it's over the intersection of 31 to 60 and moderately depressed. Okay, so the intersection remained the same of that 64, right? On the bottom, though, was the total of the moderately depressed people. Okay, and the moderately depressed people were at 184. So that goes on the bottom. We divide that and we should have gotten about 35%. Any questions over that? We're good? Okay, next. Okay, sometimes you'll be given a chart that isn't completely filled out. Okay, in a survey, students and parents are asked if they would like school to start an hour later and end an hour later. So would you rather start school at, like, let's say 8:40 and then get out at 3:40?
How about like 8:40 to 2?
Okay, well, we're not talking, that's not the question that was asked. Okay. And who wouldn't be like, yeah, sure. Okay, so, right, and then would you rather have that or would you rather have what we currently have? Okay. These people answered these questions. Now we need to fill this in. Any ideas on how I'm going to get this missing piece? Oh, good. These two should add to equal this. So to go backwards, you have to subtract them. So this is 326 minus 187, which is going to give me that total, which should be 139? Yeah. 139. These two, we should add these two to equal it to this. And we should get 372. This one, we're going to add this way. And it should equal 303. Okay. And then this one we're going to add this way as well. And get 395. And then our total of totals would be 698. Okay, so in your homework, you're going to have to complete the chart like this. Okay, then we're going to ask those same questions. Okay, again, we haven't given that. The probability of yes, given they're a student. So I'm only going to look at students. So on the bottom is my total of students. And on the top is the intersection. Of yes and students. So we're going to look at our chart. So the total of students is 303. The intersection of students and yes, where they intersect. What's the intersection, you guys? Well, oh, good, okay. You guys scared me there for a second. So then we divide that. So I get 0.617. Does the 7 make the 1 go up? Yes. So it's 62%. Any questions over that? Yes. It's the intersection of yes and students. So if I did this, where do they intersect? 187. Any other questions? Okay, you guys do H and J. Yes, parents. Yes, given they're a parent. And then parent, given that they said no. Okay, Alyssa, what did you get for H? Okay, what was your fraction? 139. Oh, sorry, on top. 139 over what? 395. And that gave you about 35%, you said? Any questions over that? So you should have the total of parents on the bottom, and our total of parents were 395 over the intersection of yes and parents. The parents who said yes was 139. Any questions over that? Okay, Jay. Celeste, what'd you get? Okay, what was your fraction? 256 over 395. Okay, so you're going to be doing the people who said no was on the bottom. So how many people said no? 372. 372 said no, because no goes on the bottom. And then of those people, the parents were 256. So you do 256 divided by 372. And that gives me 69%. Any questions over that? Okay. Now we're going to take a Venn diagram and put it into a chart. Okay, so we have to read. The following Venn diagram shows the information from a survey. The survey asks 2 questions. Are you male or female? And which do you prefer, vanilla ice cream or chocolate ice cream? Use the Venn diagram to create a chart. Okay, so we can create this a couple different ways, and if yours doesn't look exactly like mine, that's okay. Because we can put male and female here. We do it male and female here, chocolate and vanilla here, or we could do chocolate and vanilla here, and male and female here. Does that make sense? Okay, I'm going to put male here, female here. I'm going to put vanilla, and then chocolate. And this is my total. Oopsie. And my total. Any questions over that? The place to start is in the middle. You're going to start with these people. They're the easiest people to place. Who are these people? They are and male and chocolate. Male and they like chocolate. Oh, and I didn't, that's not the right number. 96. Okay. If these are the people who are male and like chocolate, who are these people then? Males who like vanilla. So these are the males who like vanilla. We can find the total by adding these two then and get 152. Good. Okay, now the females are a little trickier. Okay, these people. Who are these people? They're not male, so they're female who like chocolate. Okay, then these people, they're not male, so they're female. They're not chocolate, so they like vanilla. So this is 65 here. Any questions over that? So we can add up and get all these totals. This is 150 here. This is 302. This is 181. And this is 121. Any questions over that? All good? Okay, we're going to skip these because we've already gone over those probabilities. It's just going to be using these numbers. We need to go back to the back and do a tree diagram. So let's teach you how to use a tree diagram. Okay, of all the respondents, 17% are male. Of the male respondents, 33% are left-handed. Of the female respondents, 90% are right-handed. Okay, so at the beginning, we have 1 is male. And the males are 17%. So we're going to write it as a decimal, 0.17. Female then. You take the 17% and you subtract it from 100% to get the percent that were female. Someone turn it off, please. And that would be 83%. Any questions over that? Do you guys get where I got the 83% from? Okay, you're always going to subtract from 100. Then we can either be right-handed or left-handed. Okay, and then left-handed. Okay, left-handed are 33%. Then I have my 100%, and I'm going to subtract it from 33% to get the 67%, 0.67. So I changed, I need to be consistent. Not make this this needs to be a decimal, 0.33. Any questions over that? Okay. Then we need to find the probability of the both. So we multiply 0.17 times 0.33. That gives me here, oopsie, 0.056. Does this make the 5 move up? Yes, so this is 6% here. Okay, then we're going to have this one is 0.17 times 0.67. Which is 0.11. So 11% goes here. Any questions over that? Okay, the bell's about to ring. So we're going to stop right there for now.